Hi, everybody, and welcome. This is Miss Nislonsky again, and I am doing a lesson with you today on different types of angle pairs. And a lot of this you'll find is a review from things that you've learned already in middle school. So hopefully this shouldn't be too bad and an easy topic to get through. So we have a little bit of notes to take. So feel free to pause this video as you're watching it to write down the vocab words. Make sure that you include everything that's on here, all of the different types of diagrams, because every single diagram is different and shows a different type of example. So we're going to start off with complementary angles. Complementary angles are any two angles that add up to 90 degrees. And so you can either have them touching, or we use the word adjacent, and that's when they end up sharing a common side or ray. Or you can have them completely separate. And as long as they both add up to 90, then we can say that they are complementary angles. The other type of angles is supplementary angles, and these add up to 180 degrees. So same concept as the complementary ones. You can have them either adjacent to each other, where they share a common side or ray, or you can have them completely separate from each other. As long as they add up to 180, they are supplementary angles. And now you'll see some notes, some drawings on the left-hand side for how to remember which one adds up to 90 and which one adds up to 180. So here's a cute little trick for you. If you draw a line going straight down from the C in complementary, it looks like you're turning it into a 90 with that 0 from, or the O from complementary. So that can tell you that complementary, they add up to 90. And then with supplementary, you can add a 1 in the front, close off that U to make a 0, and the S, put a diagonal through it, and it looks like you're creating a 180 out of the supplementary word. So moving on. So again, adjacent angles, I already touched upon this. These are going to happen when they end up sharing a side and a vertex. So as you can see here, for instance, angles 5 and 6, they have this purple dot, that's the common vertex. And then the green squiggly line, that is their common side. And then here's just another example. A linear pair occurs when we have two angles. They are supplementary and they are adjacent to each other. So this is one of those cases where it has to meet both types of criteria. So they have to be both supplementary and adjacent to each other. So they're always going to look like this diagram here. And then our last type of special angle pairs are vertical angles. So vertical angles are the ones that are, if you think about it, as opposite each other. So you can have, for instance, angles 12 and 14 or angles 11 and 13, and those are vertical angles. And we have a special relationship between them. Whenever you have vertical angles, they are always going to be congruent to each other. In other words, they have the same measure. So for instance, angle 11 could be 30 degrees. That would mean angle 13 is also 30 degrees. So they are congruent when they are vertical to each other. And you get that whenever you have any two lines crossing over like that. All right, so now we're going to go into some practice using those vocab words that we just learned. So we're going to use this diagram here, and we're going to find an example of each of them. So if we want to look at a pair of complementary angles, since we don't have any angle measures here, we want to look at only angles that would be adjacent to each other, because we can't necessarily mix and match. So what we could see here is we have just a right angle here, But I can't say that just one angle is a complementary angle because it needs to be a pair of angles, meaning two angles. So in other words, we want to look at which two angles would form this type of right angle. So you can look at it as right next to it on the left-hand side, we have angles 1 and 6 forming a right angle as well. So we can say angles 1 and angle 6, or we can also look at angles 3 and 4. So, or angle 3 and angle 4. And just like Mr. Montana said in his previous video, you can either write the angle symbol as though it's like a less than symbol, or you can put an arc through it. Both are considered correct. It's just a matter of preference. So now let's look at supplementary angles. So here we have no two angles that are adjacent to each other that would be forming 180 degrees. We have three, for instance. We could say that angles 1, 6, and 5 all together form a straight line, or 4, 5, and 3, or 2, 3, and 4. But the problem with this is that all of those require three angles. And when we talk about complementary and supplementary angles, we always want to look at a pair. So here we want to see maybe there's an option for finding a pair of non-adjacent angles. And since we have this right angle, we know that two right angles could give us supplementary angles. So is there another one single angle that could form another 90-degree angle? And there is. If we look at angle 5 here, that one is also considered a right angle. So we can say angles 2 and angle 5 are both going to be supplementary angles together. Now, when it comes to vertical angles, it's always the ones that are just opposite each other. So we can have angle 1 and angle 4. Angle 1 and angle 4. And of course, you only have to name one example of each, but I am going to go through all of them, especially for this one. We could also have angle 6 and angle 3. Now notice that I drew two arcs here. That's to show a different pairing so that I'm not comparing it to angles 1 and 4. If I had everything having only one arc in my drawing, that would show that every single one of those angles is the same measure. But I don't know that. And if I were to just go based off the diagram, it definitely looks like angle 1 is larger than angle 6. Of course, we can never go based off the diagram, but that's why we're marking it with one arc versus two arcs, and then my next example, I am going to use three arcs. So we can say for the last one that angle 5 and angle 2 are also going to be vertical angles. Okay. Now, when it comes to adjacent angles, we've been talking about this a lot because we mentioned it with complementary and supplementary angles. We can look at adjacent angles as any two that are right next to each other. So I'm not going to bother writing these out, but you can have angles 1 and 2, or 2 and 3, or 5 and 6, any of those that are right next to each other. And then for a linear pair, we want to see if we have any that are both supplementary and adjacent to each other. Now, in this case, the ones that we said that were supplementary were angles 2 and 5. And those are not adjacent to each other. So that means that we actually cannot figure out, or we don't have any linear pairs in this example. So we're going to write none because they are not adjacent. So we do have supplementary angles, but because they're not adjacent to each other, we actually don't have an example of a linear pair in this example. So now let's just start with these examples. I'm going to let you guys pause the screen and pause the video, try them out on your own using their relationships. So you'll either be adding them to a total sum of 90 degrees, or maybe a total sum of 180 degrees, or maybe if they're congruent, you'll be setting them equal to each other. So try that out, pause the video, and then you'll check your work in just a moment. All right, so here are the answers to these 4 problems. Our first example, you want to be setting them equal to a total of 90 degrees because you do have the right angle in here. So that means you're forming 90 degrees. So 2x plus 6 plus 4 plus 6x equals 90. You should be getting a solution of x equals 10 in the end. But then the directions said they wanted you to find the missing angles. So you need to substitute back in for x, and you would get 26 degrees and 64 degrees. And of course, you can always add them together. 64 plus 26 does add up to 90. That's how you can check your work. For the next one, we had a pair of vertical angles, which means I'm going to set them equal to each other. You end up getting x equals 8 as a result. Plug it back in. You get 40 degrees and 40 degrees. Of course, you know that you did it correctly if you end up getting the same answer, because if they are congruent, their measures are equal to each other. And then because we have a straight line going here, we know that these 2 angles have to add up to 180 degrees. So if you subtract 40 degrees from 180 degrees, you would end up getting 140 degrees. And that goes for both the top and bottom angle. Then we have on the bottom left, we have a pair of supplementary angles, or you can look at it as a linear pair. Either one is correct. So add them up, set them equal to 180. You get x equals 31 as a result. Plug it back in, and you should be getting 56 degrees and 124. You can get the 124 by looking at these as vertical angles over here, or by subtracting 56 from 180 degrees. And then our last one, same exact concept. You're adding them up to 180 degrees. X equals 17. Plug it back in, and you get 75 and 105. And for all of these, you can always double check your answers to see if it adds up to 180 degrees. All right, everybody. See you tomorrow.